For months, humanity held its breath, counting down to October 3rd, the day NASA promised would change everything. This wasn't just another press conference or routine astronomical update. This was the moment the world would finally learn the truth about 3I Atlas, the mysterious interstellar visitor that had every major observatory on Earth locked in obsession. Scientists, journalists, and amateur stargazers alike had peppered NASA officials with the same urgent question. Was this thing a comet, or something far more advanced, perhaps even artificial? The response was always measured, always cryptic. Wait for the high-resolution images from Mars, they said. When 3I Atlas makes its closest approach, just 29 million kilometers above the red planet's surface, our orbiters will capture everything. Then we'll know. That promise became a global phenomenon. Social media exploded with speculation. News networks prepared special coverage. Amateur astronomers trained their equipment toward Mars, hoping to catch even a glimpse. The entire planet seemed to pause, waiting for that single photograph that would either confirm our loneliness in the universe or shatter it completely. October 3rd arrived with the weight of history pressing down on every shoulder. But when scientists and reporters rushed to NASA's official channels, desperate for the revelation they'd been promised, they found nothing. No images, no data, no answers. Instead, every major NASA page covering 3I Atlas displayed the same frustratingly vague message: under maintenance, unable to update. The timing couldn't have been worse, or perhaps more suspicious. At the exact moment of the Mars flyby, 3I Atlas was positioned on the far side of the Sun, directly opposite Earth's location in space. This meant no telescope on or orbiting our planet could capture it in real time. The Sun's overwhelming glare made it completely invisible from our perspective. The only instruments with a clear view were those orbiting Mars, spacecraft belonging exclusively to NASA and the European Space Agency. And those eyes in the darkness stayed eerily silent. So what had the Mars orbiters actually captured that was so disturbing it couldn't be released to the public? Inside the scientific community, anxiety began spreading like wildfire. Whispers circulated through research institutions and university departments. Some scientists speculated that what NASA witnessed was simply too shocking to reveal immediately, that releasing the data might trigger global panic and societal breakdown. Others suspected something more calculated, arguing that the so-called technical shutdown wasn't a malfunction at all, but a deliberate strategy to delay disclosure until government officials decided how to spin what they'd discovered. But nobody truly knew what was happening inside NASA's locked rooms, where the 3I Atlas data had vanished, or what those missing Mars photographs might have revealed. While the public stared at blank NASA pages, refreshing browsers in desperation, one astrophysicist decided to break the silence. Drew Doss, a relatively unknown but meticulous researcher who'd been obsessively tracking 3I Atlas for months, posted a 9-minute video clip on Twitter late on October 3rd. The footage, stitched together from Perseverance rover images, showed a faint streak crossing the Martian sky. Frame after frame, the streak refused to match the predicted stellar motion patterns. When Doss overlaid NASA's own published trajectory calculations for 3I Atlas onto the images, something didn't align. The object wasn't where NASA claimed it would be. It wasn't moving on the path their models predicted. But using publicly accessible spectroscopy software, Doss identified its chemical signature. The mixture of ionized gases, the unusual nickel composition without corresponding iron spikes, and the peculiar plasma glow matched exactly what had been measured from 3I Atlas for months. In other words, this wasn't some different object or imaging error. It was still 3I Atlas, the same interstellar visitor. Only now, inexplicably, it was traveling off course. That realization sent shockwaves through the astronomical community because celestial objects can fragment, brighten, or develop tails. They can even break apart entirely. But their orbit, their fundamental path through space, is supposed to be one constant that doesn't change unless acted upon by massive external forces. Yet, here was 3I Atlas traveling on a completely different trajectory than every published prediction suggested. How is it even possible for an object's course to spontaneously change like that? Until October 2nd, NASA's official trajectory was crystal clear and stable. 3. I-Atlas would pass Mars on the 3rd at approximately 0.2 astronomical units, roughly 30 million kilometers away, skim past Jupiter later in the month, then loop dangerously close to the Sun between October 29th and 30th before heading back out into the infinite darkness of deep space. Every calculation from every institution agreed on one crucial point: zero risk to Earth. Our planet was safe. But when DOS's CLIP and telemetry data from both the Perseverance rover and ESA's Trace Gas Orbiter were carefully reviewed by independent analysts, they noticed something that couldn't be dismissed as instrument error or calibration drift. The object wasn't where it was supposed to be. It had shifted inward, only a few arcseconds off course. But in the vast scales of space, that tiny deviation translated into something absolutely alarming. 3. I-Atlas had moved nearly 2 million kilometers closer to the Sun than predicted. Initially, scientists assumed this had to be an error, perhaps a timing glitch in the imaging sequence or maybe a result of coordinate system miscalibration. But then, China's Tianwen-1 orbiter and the European Mars Express returned identical readings from completely independent systems. The trajectory shift was undeniably real. So, what exactly happened? Renowned physicist Michio Kaku described the situation as a textbook example of how minuscule variations in the cosmic dance can cascade into catastrophic outcomes. His initial explanation centered on gravitational mechanics. As 3 I-Atlas flew past Mars, it didn't follow the precise altitude that scientists had calculated. It passed lower than expected, perhaps only by a few hundred kilometers, but that meant dipping deeper into Mars's gravitational well. That small difference acted like a cosmic slingshot, stealing just enough of the object's forward momentum to pull it slightly inward toward the Sun. But even Kaku admitted that gravitational perturbation alone couldn't account for the entire deviation observed. Around the same critical moment, ESA's Trace Gas Orbiter recorded an unexpected spike in plasma emissions near the object, a clear indication that part of its surface had vented violently. In the vacuum of space, when superheated gas bursts explosively from one side of a body, it creates thrust, a natural rocket engine effect that pushes the object in the opposite direction. That combination, the gravitational tug from Mars coupled with the outgassing thrust, altered 3 I-Atlas's velocity by just 4.966 meters per second. That's less than the pace of someone jogging down a street. But in the frictionless vacuum of space, where trajectories stretch across millions upon millions of kilometers, that's all it takes to fundamentally rewrite the future. That microscopic nudge sent 3 I-Atlas drifting off its predicted course, not safely away from the Sun as originally calculated, but dangerously toward it. The new orbit is tighter, faster, and alarmingly unstable. Instead of leaving our solar system as planned, updated computer simulations now show the object's path slicing directly through the exact plane where Earth orbits the Sun. It's a shift so subtle that no telescope on Earth would have detected it if Mars's spacecraft hadn't been positioned perfectly to observe. Yet that minor cosmic slip may have just transformed an interstellar visitor into a legitimate planetary threat. Because simulations run by MIT researchers and independent observatories around the globe reveal something that shouldn't exist in probability calculations: a 45% chance that during its next pass between November 15th and 27th, 2025, 3 I-Atlas will cross directly through Earth's orbital plane. In many computational models, it misses us, but barely. Some projections show it skimming through our upper atmosphere before shooting back into deep space. But in other simulations, equally valid mathematically, it doesn't escape at all. It plunges straight toward us. And even without direct collision, the consequences could be absolutely catastrophic. The object's immense gravitational field and powerful electromagnetic signature could severely disrupt Earth's magnetosphere, distort atmospheric circulation patterns, and throw global weather systems into complete chaos. Power grids could fail simultaneously across continents. Satellites could lose orientation permanently. Communication systems might collapse entirely, but if actual impact occurs, we're looking at something beyond comprehension. A 5-kilometer-wide interstellar object weighing nearly 33 billion tons, traveling at 68 kilometers per second, would release more energy than 50,000 Hiroshima bombs in a single instant. For perspective, consider that the asteroid that wiped out the dinosaurs 66 million years ago, the infamous Chicxulub impactor, was only twice this size and was traveling considerably slower. Even a glancing blow would be sufficient to ignite portions of the atmosphere, flatten entire continents, and plunge the planet into a years-long nuclear winter. An ocean impact would generate tsunamis hundreds of meters high, racing across entire coastlines at impossible speeds. Civilization, as we understand it, wouldn't end in fire and explosions. It would end in silence, suffocating dust, and endless darkness. And that's precisely why the deafening silence after October 3rd feels so haunting, so deliberately orchestrated. For months, Harvard astrophysicist Avi Loeb had been quietly but persistently warning NASA to treat 3I Atlas as far more than a routine comet, to monitor it with the same deadly seriousness as an incoming asteroid on a collision course. Each time, the agency's response was identical, almost scripted. It's a natural object. Its trajectory is safe. There is absolutely no risk to Earth. But now, the numbers tell a completely different story. Something fundamental changed, and nobody in authority is explaining to the world just how dramatically the situation has deteriorated. At the precise moment when transparency was most critical, NASA announced that due to budget constraints and low funding, key operations and missions were being temporarily suspended. But what nobody could satisfactorily explain was why the trajectory had shifted so suddenly and so significantly. Avi Loeb, who had been among the earliest mainstream voices to call 3I Atlas anomalous, told a podcast the following morning that the new trajectory calculations were alarming, not merely because of the object's proximity to Earth, but because of what they revealed about its fundamental nature. This object had endured the Sun's most powerful coronal mass ejections without developing the characteristic tail that comets display. It maintained a mass estimated at 33 billion tons with an internal energy output approaching 10 gigawatts at its core, levels that seemed impossible for a passive rock. Its spectroscopic analysis showed nickel concentrations without corresponding iron signatures, a composition pattern that's only found in industrial-scale production processes, a potential sign of advanced technology. It had mysteriously accelerated from 60 kilometers per second to 68 as it approached the Sun, and now, apparently, it had deliberately altered its course. But the possibility Loeb hinted at was far darker than simple miscalculation. If 3I Atlas isn't natural, if it's some form of probe or vessel, then its behavior might not be random accidents at all. That would also explain its uncanny alignment with the solar system's ecliptic plane, its near-perfect timing with signals from deep space, and its ability to absorb rather than reflect energy under intense solar assault. And anything capable of changing trajectory once, Loeb warned ominously, can certainly do it again. Elon Musk later entered the discussion in his characteristic style, stating during a live stream that 3I Atlas doesn't resemble a rock anymore. It looks like an advanced civilization's probe, possibly even a functioning spacecraft. Musk pointed out that while a gravitational slingshot could theoretically alter an orbit slightly, it couldn't produce this level of timing precision and directional accuracy. The trajectory shift occurred at the exact optimal point where a controlled propulsion burn would produce the most efficient inward turn toward the Sun, precisely the kind of maneuver that SpaceX engineers employ for deep space navigation missions. If that assessment is accurate, we might not be tracking a comet at all, but rather a functioning probe deliberately sent by an advanced extraterrestrial civilization, possibly testing our detection capabilities and response protocols. And if an object can correct its course deliberately once, it can certainly do so again. This time, its projected path isn't safely beyond Mars or Jupiter. It's heading directly toward the same orbital plane where Earth circles the Sun. where we'll be in just a few weeks. So, did 3I Atlas really change its path through pure accident? Or did something intelligently guide that change? The implications are staggering and terrifying in equal measure. What we're witnessing might be the most significant moment in human history. The confirmation that we are not alone, and worse, that we've been noticed by something far more advanced than ourselves. The question now isn't whether contact has been made. It's whether we're prepared for what comes next, and whether October 3rd marked not a technical failure, but humanity's last moment of blissful ignorance before everything changed forever.